So we have to remember a couple of things in this problem. One, it's a division problem. Raul, if I see your phone out, Eduardo, put your phone away. Let's go. We're doing math now. Kenneth, put your phone away. Okay? I don't have my phone out. All right. So when I have two things to think about, one, I'm dividing. So I know I'm going to first rewrite this as a multiplication problem. And what do I need to do with the multiplication? Make it multiply by the reciprocal. So I'm just going to put the denominator in place of the numerator and the numerator in place of the denominator. The second thing I have to pay attention to is the negative exponents, and that's what I think freaked a lot of us out. What do we do with those negative exponents? Well, what is being raised to the exponent in this case? The x or the 5 or both?
The 5.
Only the x. If it were both, there would be a parenthesis around them, okay? And there's not. So only the x. What's being raised to the power in the denominator? Only the y. So when I have negative exponents, I have to put them in the opposite place in the fraction. So I'm again going to rewrite this now. The first one doesn't have any negative exponents, so it stays the same. But this one, the 5 and the 6 stay where they belong because they're not being raised to any exponents. But the negative exponents change and they become positive exponents. Remember that from earlier in the year? Okay. Now it looks just like a problem we know how to do. The thing we have to be careful about is that these two numbers get multiplied together and these two numbers get multiplied together. What do I do with the exponents?
Wait, does it go across?
I add. Good. Straight across. That's how I multiply fractions. So 3 times 5 is 15. And then I have x to the third and y to the third. I can't actually add those exponents because the bases are different, right? If there were both x's in the top, I would add the exponents. But I just leave them for now, okay? And again, the bottom, we're going to have 30 x to the 5th y squared. Now, if you look at this, I have to think about for a minute, what do I do with these numbers in the front? Yes. What do I reduce it to? 1 over 2. Isn't 15 half of 30?
I know, I said 3.
3 over 6, which continues to reduce to 1 over 2. So I can put a 2 in the bottom. I can put a 1 if I want to, but I don't need to. Now I'm going to worry about just the x's. What do I do with those exponents, Alexis? You were saying it earlier. Right, okay, because they're divided. I subtract the exponents. There are 2 more in the denominator than there are in the numerator, so I will put x squared down here. Okay? With the y's, there's how many, Travis? Where is it? Right, so I'm going to put 1 y up here, and that's the answer. Okay? It does say state the restrictions on the variables. We'll do that in a minute. Yes? Because this is a negative exponent, so I moved it up to the numerator and made it a positive exponent. Okay? And I did the same thing with the x to the 5th. Moved it down to the opposite part of the fraction and made it positive. That, anytime there's negative exponents, that's what you do. Okay? So this was two steps. Change the multiplication and take care of the negative exponents. Okay? Kind of a double whammy there. What restrictions on the variables are there? What can't be 0? X can't be 0. Would you agree? Because you can't divide by 0. And then if you look at the original problem, y can't be 0, right? So it's just x and y both can't be 0. That would be the restrictions on the domain. Well, just restrictions because it depends on if it's x or if it's y. Okay? All right, what other one did you guys?
I don't get what the domain.
Well, you can't divide by 0. So y can't be 0. And if you continue to look down here, x can't be 0. Moody.
I added a cross with the negatives, and I switched their spots to n.
And you get the same answer. Yeah. There's more than one way to get to that, and that's okay, as long as you're using the correct steps or correct math properties. That's fine. All right, so the next one we want to look at is number 28. This one, I believe, has some factoring involved. That one didn't have any factoring, but this one does. So tell me, when you look at this one, why it's factoring and the other one was not. Because that's a big deal. That's a difference, right? Why does this one require factoring? I see quadratic, and I see a trinomial. So we know, because of these pluses and minus signs, and because it's quadratic, we know we should be factoring. These factoring problems are a little bit more difficult than some of the others because there's a 2 here. Here is something that someone in my last class yesterday tried to do. Tell me what's wrong with it. Just watch. Why can't I do that? Travis, why can't I do it? Not because of the exponents. No, not because of that. Christian, I have to factor first. Because of these pluses and minuses here, I cannot cancel just part of it. They would have to be factored, and then I would be able to start reducing. So please make sure you're aware of that, okay? So we're going to factor the numerator first, and then we'll worry about the denominator. Now, this one's a little bit more difficult. So I'm going to kind of do a little bit off to the side. 2y squared plus 8y minus 24. Thank you. April, good job. Isn't there a GCF?
Yeah, I put the 2.
So take a 2 out. You always look for that. Very good. Y squared plus 4y minus 12. 2 times 12 is negative 24. So the 2 stays there. So we know there's going to be a 2. And now we're going to worry about factoring what's left. Y. What 2 numbers multiply to be negative 12 and add to be 4? Positive 6 and negative 2. Good. All right, so I have factored the top. Now I need to worry about the denominator. Is there also a GCF there? Great. So when I'm going to erase this part. We're just going to factor the bottom now. So I'm going to take out, what's the GCF in that bottom? It's also a 2. Good. Okay. And the 2 stays there. And I'm going to, well, when you take a 2 out, you got to take a 2 out of everything. Right? Y minus 2, y minus 2. Good. Because negative 2 times negative 2 is positive 4, and negative 2 plus negative 2 is negative 4. So that's right. So what can I cancel? I heard the positive 2's. Yep, there's one in the numerator, one in the denominator, and the y minus 2's. So what's left is, that was weird. All right, so what's left is y plus 6 over y minus 2. So that's the simplification portion. But now what do I do in terms of what are the restrictions? How many restrictions do you see? Well, isn't the factor that cancels out the same as the one that's still in the denominator? Isn't it just y minus 2? So the only restriction would be 2, okay? Or y can't be 2. But you should look at what you canceled out and what's still left down there. Yeah, 2 can't ever be 0. So you wouldn't worry about that one. But if that was just a plain x, then you would say 0. Okay? Good question. Tim, you got to put your head down, babe. Do you hear me? It's school rules. Same reason you can't have your phone out. Last one, 48. Okay. And I'm kind of disappointed more of you didn't get this one. But here we go.
It actually great.
It did like last month.
I knew this one. And when you be in car, bro.
Travis, you can tell me how to start it for sure. Okay, and you'll finish writing it first. All right, so when you look at this is a complex fraction, okay? Travis, tell me the first step that I need to do. Shh. Very good. I'm going to rewrite this as a division problem that we like to look at, okay? Which means that I'm going to take this division bar and make it as a division sign. And this is what everyone should do, okay? Period. So let's try that. So we're going to rewrite this now as the numerator is just this fraction. And Travis is right. I'm going to make it divide by, and I'm going to write the other side. 12m plus 8n over 5m squared. When it's written side by side like that, it's a little bit more comfortable for us. Joseph, what am I going to do next? Okay, factor. Okay, let's do some factoring. Are you savvy enough to factor and flip at the same time now? I can rewrite it as multiplication and flip the second one and factor at the same time, maybe? We know we have to make this multiplication. I know that's going to go up here. What is the factoring? What goes out here? What's the GCF here? 4. Good. When I take a 4 out, what's left? 3m plus 2n. Good. So I factored the right and flipped it. Notice when I flipped it, I did make it from division to multiplication. All right, the first one doesn't flip. But what's the GCF in the numerator here? Again, okay, what? A 3. 3, and what's left? 3m plus 2n. Ooh, interesting. Okay. We can, now because it's multiplication, I can treat this kind of like one big fraction bar, right? And I'm looking, yep, and I'm going to reduce some stuff. Shamar, what you looking at? Which ones? Okay. You mean the domain stuff? We'll worry about that in a minute, okay? Huh? Yeah, so now we're going to keep going. I agree. So I have an m squared I can cancel. I agree. Is that it? I think so, right? So what's still left in the numerator? 3 times 5, so there's a 15 up there. And then what's left in the denominator? 4m squared. So that's how it simplifies. I agree. But what are we talking about? What's a domain restriction? Okay? Or what's the restrictions on the variables? I take the m squared and I set it equal to 0. So we know that m can't be 0. Would you agree with that? All right? Just square root both sides is fine. And then this other one, 3m plus 2n can't be 0. That's kind of weird because there's 2 variables in there. Would you agree? So let's see how the book told us to write our answers with that domain restrictions, because these are the restrictions. Okay, are here. This one, and then let's see what the book said. They said, well, m can't be 0. M can't equal negative 2/3 n. So they solved it for m in both cases. That's fine. So in other words, they solved this for n. So m can't be negative 2/3 n. That's all right, because 3 times 5.
So what about the 3 times 3?
Honey, that canceled.
Yeah.
That's why it's there. Okay? Now, there's still another restriction. Those 2 are the only restrictions for where the factor is canceled. What else do I need to look at? Where the denominator equals 0, right? So where 4n squared can't equal 0. If I divide by 4, 0 divided by 4 is still 0. square root, n can't be 0. So all of these and written in black are the domain restrictions. The denominator can't equal 0. Because it's where the denominator can't equal 0. So the restrictions are where the factors can't equal 0, that canceled. So that's where these came from, right? And then the other domain restriction is where the denominator can't equal 0. That's where that one came from. It's the same restrictions every time. And that's where the vertical asymptotes are. Remember, the holes are where the factors cancel. The denominator is where the vertical asymptotes are. Okay? All right. Huh? Yeah. Go ahead and take your notes out if you would. We're going to look at a couple of different problems today. And again, I'm going to give you some graded classwork for us to get some grades on solving these equations. So you will need a calculator as well. So go ahead and get both those things out for me. We know what an extraneous solution is, don't we? Remind me what that was and when we've seen it before. Extraneous solution. We did it not with parent functions. We did it with the square root functions. Remember that? And when we square... Well, extraneous just means it's an extra answer that shows up when I solve it. Okay? You're thinking of asymptotes. Okay? But what an extraneous solution is one way it can happen is if you square both sides of an equation to get rid of the radical, then sometimes an extraneous solution can be introduced. Not yet. Nope, don't have to write anything down yet. But when we solve these rational equations that we're going to do today, that's yet another way that extraneous solutions can show up. How did we, to make sure, how did we check to see if it was extraneous or not? There's two ways. If we solve it and we get an answer, how do I check to see if it's one of those extra answers or not? Do you remember? There was a calculator way. Do you remember how to use a calculator? Graph it. And where do the solutions show up on the graph? Well, it depends, but we're going to look at that today, okay? Sometimes it's where it crosses the x-axis, if it equals 0, or if you have two things equaling each other, it's where they cross. So we're going to look at that today. The other way is if we just plugged it in to the original problem and see if I got the same answer on both sides, okay? So we're going to look at an equation, and this is it right here. So go ahead and write this example down into your notes if you would, please, this guy right here, okay? We're going to solve it. Okay? Notice I have x's on the left-hand side and the right-hand side of my equation. Notice that I have x's in the denominator on both sides of my equation. Okay? This is a rational equation because it's rational because there's x's in the denominator. And I'm asking you to solve it. If you remember back in the day when you were asked to solve equations with fractions, let's look at one possible way that you were told. So for example, if I had 2/3 equals x over 10, do you remember how you would solve that equation? So we know one way to solve. Would you agree? We can cross multiply. Here's another possible way. Let's make this a 9. Okay? Actually, let's make it a 3. We'll start off easy. I could cross multiply, but I know just from looking at this that x is just 2. X is 2. Why do I know that? It has to be. Why does it have to be? Because they have a common denominator. The denominators are exactly the same in this case. So I can just set their numerators equal to each other. And that's exactly what we're going to do here. Because I think by cross-multiplying in this case, it's going to make it a little hard. Okay? We can do it, but it might make it more algebraically intensive. So what I think we should do is look at the denominators. Are they the same? So isn't the LCD, the least common denominator, just x plus 2? Great. So if that's the case, then can't I just set the numerators equal to each other? And that's what I'm going to do. So I'm going to say that x minus 1 equals x squared plus 2x minus 3. I'm just going to write the equation. If the denominators equal each other, we can simply set the numerators equal to each other.
Could you just cross out the denominator?
Well, we don't cross them out, because the reason that it algebraically works, Christian, is if I multiply both sides by the denominator, then yes, they do reduce that way. But the reason that that works is because I'm multiplying by the denominator. Are you trying to skip? Did it just, where'd it go? There it goes. Oh, okay. I think it's this shirt is touching the smartboard. Okay. Not yet. I just made this up. This is like a separate example. I said, remember that if we have two fractions that equal each other and their denominators are the same, I can just set the numerators. This is just x equals 2. This is a recall. We should know this already. Okay? Let's take that knowledge that we already know and apply it to the new stuff. These denominators are the same, right? These denominators are the same. Okay, I'm trying to make it so. Anyway. You don't get this part? 2/3 equals x thirds. They're both 3, so x equals 2. I just put the numerators equal to each other. Done. In a sense. X equals 2. They just equal each other. Same thing here. The denominators are the same, so I just set the tops equal to each other. That's what I did. That's all I did. That's all I did. Once I have this equation, I'm going to box it in. This looks like something we did a couple of months ago. What kind of equation is it? Quadratic. How do I solve a quadratic equation? Very good. I'm going to get it equal to 0. So I'm going to get it equal to 0. I'm going to move the x over, so I'm going to subtract the x from both sides. And I'm going to add 1 to both sides. So what do I have on the right-hand side? X squared plus x. Y'all, this is creepy. Why does it? There. What now? Minus 2. Good. Hopefully it's one we can factor, because if we can factor it, we can solve it quickly. If it's not factorable, quadratic formula you could use to solve it, but let's see if it's factorable. What two numbers multiply to be negative 2 and add to be 1?
Well, so you just gotta flip that? 2 and negative 1.
What are my two solutions? Negative 2 and positive 1. My question is, are either of those extraneous? How would we check? Chris said, well, one way we did it before was graph it. I'm okay with that. Let's do that. Let's graph it. Okay? So we're going to make sure both of these answers are solutions. We're going to need to check. So let's plug this into the calculator. We've got to go back to the original problem. How do I plug that original problem in? Good grief. Thank you. The left-hand side is y1. I agree. Someone said Miss Macker. What? My puppy in her crate. It doesn't actually. I just typically do the left as y1, the right as y2, but it doesn't really matter. Oh, that's my puppy. I was wondering where you got that from. The picture's in the background. Okay, so x minus 1 is in the numerator. How did I get that fraction in my calculator? How did I get the fraction? Alpha y equals. Good. So I have x minus 1 And then I have x plus 2. Go to y2. Travis, your calculator's not even open, my dear. Let's go. You want to borrow one for today? You got one, Eduardo? Okay. I'm going to go and plug into y2. You can plug it in at your leisure. You can also plug your answers in and see which one works. I can tell you right now that -2 is not a solution without the calculator. Do you know, Raul, why? Because the denominator, it's a restriction, isn't it?
Can't you just
-2, if I plug -2 in, wouldn't I divide by 0? So don't I know that -2 automatically doesn't work? But we'll go ahead and graph it anyway. So I have this rational function. I'm looking for where they equal each other, where they cross. I'm going to check the calculator, go to the table. I'm looking at -2. What do you see across the board? So what does that mean? That's an extraneous solution. It's actually a vertical asymptote on both.
So it works?
-2 is extraneous. It doesn't work. And what was the other one that was a possible answer? +1? And doesn't +1 have an answer in both cases? So the only solution is 1. So this is going to be our extraneous solution. So x equals +1 is the only one that works.
That's what we're looking for.
Yep. And again, if you don't want to use the calculator, if I plugged in -2 up here, wouldn't I get a 0 in the denominator? -2 plus 2, which would be, you can't do that.
-2 minus 1.
That one works. Doesn't give you a divide by 0. So that's why it works. Okay? Let's try another one. Let's write this one down. This is our second example that you're going to need to be able to do. Okay? Right. So it means 0. It crosses at 0. So if I calculate the intersection, I get 0. So that means that that is a solution. So that one works. That one? No. So that one you cross out. Okay? All right. This one's a little bit more difficult. Why is this one harder than the one we just did? No, actually it's not a trinomial. The fractions were in the last one. I had fractions.
But they're like equal numbers.
They're not. It's a binomial.
No. Isn't that different? Look at the one we had before. The other one was just fraction equals fraction, wasn't it? Fraction equals fraction. That's great.
Fraction plus fraction equals fraction.
Right, it's a little bit different. Okay? The same rule still applies, though. If I can get a common denominator for everything, then I can just set the numerators equal to each other. Okay? So our goal is to get a common denominator for everything. Okay? Can I factor this right here? Yes, I can. What's the GCF? What's the GCF? N. So I'm going to take out an N, and what am I left with? N plus 1. So we're looking for a common denominator. The least common denominator. I just factored it out. I took the GCF out. There's an N in both, N squared plus N. I just took the N out and then left with N plus 1. Reverse distribution. I'm here to tell you that what I'm about to highlight in blue is the common denominator.
So you're telling me every time I see an opportunity to factor, just factor?
Yep, I am telling you that. So if you look at the other two pieces, don't they kind of look like that a little bit? They each have a portion of the common denominator, right? So what that means is that I'm going to multiply the top and the bottom by the piece that it doesn't have. Which part of the denominator over here highlighted in blue does this one not have? Well, the n plus 1, right? So I'm going to put the n plus 1 on both the top and the bottom. Looking at the middle piece, which portion of the common denominator does it not have? The n. So I'm going to multiply it by n over n. I'm just trying to get a common denominator, and that's what I did. Now each of the denominators is n times n plus 1. Right, 2n plus 2. And n squared plus 2n. Make sure before we go on, I want to make sure you get all your thoughts clear about what I did, because we're going to move on in a minute to finish solving it. Why do I extend the line?
You know the division bar?
Yeah, I could if I wanted to, sure. I will show you how to solve one. You mean what case you couldn't get a common denominator? You can always get one, but there can be a lot more difficult ones, and you just use your calculator in that case, and I'll show you how to do that in a minute. I'll show you how to do that in a minute, okay? Combine like terms. What like terms are there? You can't, because they're fractions, in order to add them, you have to have a common denominator, right? You do.
So they're all the same at the bottom.
Yeah, now all the denominators are the same, right? They're all the same. So in this case, I can just simply say that this plus, so 2 times n plus 1 plus, I'm just looking at the numerators now. Once all the denominators are the same, now I can look at the numerators. 2n plus 1 plus n times n plus 2 equals negative 2. Once I get the denominators to be the same, I can just worry about the numerators, because equivalent fractions with common denominators, their numerators are equivalent. It's what I wrote in red that's the tough part. How did I figure that out? Where did the part in red come from? Because I looked at what it was missing. What part was it missing? Okay? Now I'm going to distribute, but before I move forward, I want to make sure you know where the red came from. You okay? It's just the part that was missing in the common denominator, that's all. All right, so now Travis, I agree, we're going to distribute. So 2n plus 2 plus n squared plus 2n equals negative 2. What kind of equation is this? Quadratic. When it's quadratic, Angela, what do I need to do? Get it equal to 0. Okay, so let's do that. Let's get it equal to 0. N squared plus, I'm going to just cross it out as I do it, n squared plus 4n. I'm going to add 2 to both sides, plus 4 equals 0. As I was writing them down, just so I keep track in my own brain. All right, I won't do that if that's confusing. Well, for some people, it confuses them, so I'll just do it in more than one step. Okay? Does it factor? It does. Good job. It's about, I told you, factoring is something you better know how to do. Where? This one? This one? No, because I'm trying to cancel. I'm trying to get this to be 0, baby. So to move it to the other side. I got it to equal 0, right? Okay.
But there's only 1, 2. Or that 2 comes on the other side.
This 2 on the right side, I moved to the left side. Okay? I want it to equal 0 because it's quadratic. So the answer I get is n is not equal, I'm sorry, n is equal to -2. That's the solution. Is it extraneous? Is it one of the extra answers? Well, if I look at my problem and I plug in a -2, is there anywhere up there that it will end up being a divide by 0? If I plug a -2 up there?
Wait, I have a question. So you got
It's not extraneous.
n squared. You got n squared. Oh, there's a 2 right there. Okay, because that n is times. Okay. Never mind.
Talking your way through it? All right.
I.
You good? Nate. Where'd this 2 go? This is just distributing this to each piece. So 2n, 2 times 1 is 2. Oh, I combined. Well, this became this one. I moved it to kind of get it in the order I wanted. Okay? Love all these questions y'all are asking. That's awesome.
Why is it equal to 0?
I always want it to equal 0 when it's a quadratic, because then I can factor it. Moody. Graph it, or check and plug the answer into the problem into the denominators. So -2, if I looked up here and I looked at all of the denominators, right? And if I plug a -2 into any of those, would I end up with a 0? No. So I know it's not extraneous. In the problem before that, Moody, if I looked at the answers, -2, and I plugged it up here, wouldn't I end up with a divide by 0? -2? That's why it's extraneous. Okay? Good question. All right. I want to show you how to do it on the calculator. Okay? So this is where kind of Shamar was asking, you know, what if I'm stuck, or what if I can't get a common denominator? What if, what if, what if? So let's go ahead and do this last one as a graphing calculator problem and see what we would do to solve it. Okay? Then I'm done with this one, yes. Okay? So this is the last one. You're going to plug it into your calculator. Remember, anytime I have an equation, what am I doing with the calculator? Go to y equals. I'm graphing what on the left side and what on the right side. Where do they go in my calculator? Okay, good. So I'm going to come over here, and I'm going to plug in, go to my y equals. I'm going to clear out what's there. This is just this is the calculator version, exactly. Remember, y1 is just the left-hand side of the equation. y2 is the right-hand side of the equation.
Oh.
That's it.
Yeah.
When I graph them, I should see 2 separate graphs. Okay, you missed the division sign. Go back and double check that you plugged everything into your y1. You see what you did wrong? Let me see. X plus 2, 1 minus 2x. Yep, that looks fine. Right. Okay? All right, looking good. Looking good. When you graph it, we are looking for what? Where they intersect. Sometimes we're looking for the zeros, the roots, the solutions, but that's when it equals 0. Here it doesn't equal 0, it equals 5. So I'm looking for where it crosses 5. And that happens, maybe it'll let me highlight it, I think it will. Oh, well, you know what it will do? Look at this, I learned this the other day. Check this out. Okay, so look. So this right here is the graph. I'm looking for up here where they cross. Okay?
Look.
How do I do that? I don't need to zoom. Calculate. Actually, the table only works if it's an integer. Calculate the intersection. Second calc, intersect. And I'm just going to hit enter 3 times. And it does up there hit. What is the intersection? Some crazy decimal, which is why it wouldn't show up in the table. Okay? If it was an integer, like a 2, a -3, a 5, then it would show up. But this one, the answer is 0.27 repeating. It means that it's extra answer. It means that algebraically it shows up, but it doesn't show up on the graph. It means you have to cross it out. It's an extra answer. All right, so 0.27 repeating is the answer. Done. And that's all you had to do. You ready? You guys good? This is an easy one, right? As long as you know how to do it. For homework or for the classwork, if there's one that says solve by graphing, show me the graph. Don't just give me the answer. You need both of these. Okay? Do a sketch and give me the answer. All right, here are the problems. They're written up here, unfortunately. Okay? You don't need to do all of them. Let me figure out which ones I want you to do. I'm going to circle them.
I forgot to do it already. Boy, Jim, look at Will. He was looking like he ran through the six.
All right, I'm going to have you do 7, 8, 10, and 11. I want you to do 5 problems, so hang on. Let's do this one. Oh, that one's just like number 8. Hang on. All right, this will be good enough. These 4 problems, okay? They're going to be 3 points apiece. 3 points apiece for a total of 12 points. Okay? Can we leave it off so you can see it? Okay? What, baby? Huh? No, on a separate sheet of paper, they need to be written. Separate sheet of paper, folks. Okay? Separate sheet. This is turned in for a grade. Now you can grab the pass. Should be back there. Let me find it. I am going to add 2 more problems from the textbook on solving rational equations that you guys are going to need to do. Okay? So these 4 problems, in addition to, so hopefully you have all 4 of them written down.
Hold on, let me write down.
If they're not written down, they will be on School Fusion in the notes for today. But they should be written down. You also need to do the following 2 problems. Ready? On page 547, you're going to do problem 47 and 48. So you have a total now of 6 problems that you're going to need to turn in. It's not a homework grade. It's a graded assignment for accuracy. We will grade them in class.